Okay, this video is about finding the trig ratios from any angle, any place along that unit circle. Alright, so what's going to happen is I'm going to give you a point. Alright, and you're going to use that point to create an angle theta. Now, what that means is you're going to have to draw a reference triangle. Okay, you're going to draw a triangle and notice this little hint. It always will lean on the x-axis. Okay, so if it's at -3, that means it's over here. My point is at -3 and a 4. That means it's right here. And it has to go to the origin. And it's going to stay on the x-axis just like this. So there's my right triangle. There's -3, and this was a 4. And I got that simply from my point. Now, I have to find my hypotenuse to be able to find these ratios. So, well, you can use good old Pythagorean theorem. -3 squared plus 4 squared equals the radius squared, or the hypotenuse, however you want to call it. -3 squared is 9, plus 16 is 25. So if r squared is 25, that means my hypotenuse is a 5. Now I know the three sides of my triangle, and this is my angle theta. Angle theta always comes from the origin. So to find my sine, remember sine is opposite over hypotenuse. So my opposite is 4, hypotenuse is 5. Cosine is adjacent over hypotenuse. Opposite over adjacent is my tangent, so 4 over -3. And then cosecant is the reciprocal of sine, so I simply flip it over. Secant is the reciprocal of cosine, so it's -5 over 3. Reciprocal of tangent is cotangent, so it's -3 over 4. And now I found my 6 ratios from a given point on the circle. Alright, look at this one. This one tells me that the tangent is 5 over 4, and something's negative. Remember, tangent is always the y over the x. So I don't know if the y is negative or if the x is negative. So that's why you have a clue right here. It says the cosine of theta is greater than 0. Alright, cosine, remember, refers to the x-coordinate. Greater than 0 means it's positive. If it's at less than 0, then it would be negative. So it's saying where the x's are the positive. Well, look at your graph. In what quadrants are the x values positive? Over here in quadrant 1 and over here in quadrant 4. Not in these two. My x values are negative over here. So I know my reference triangle can't be over here. So that means the 4 is the positive and the 5 is the negative. So remember, it's y over x. So it's -5 or 4, -5. So my reference triangle goes like this. Remember, your angle theta always comes from the origin. And now we know that the y was -5 and this is 4. I need to find the hypotenuse using good old Pythagorean theorem. So here we go. -5 squared plus 4 squared equals my hypotenuse squared. 25 plus 16 is 41. So that means r, or my hypotenuse, is the square root of 41. Alright, don't be afraid of that. It's okay. Sine is opposite over hypotenuse. So my sine is, alright, sine is the opposite side from theta. So that means it's -5 over the square root of 41. Yes, I'm going to have to rationalize that. So it's square root of 41, square root of 41. So I'm going to end up with -5 square root of 41 over 41. Yes, I can leave that just as it is. Cosine is my adjacent side over the hypotenuse. My adjacent side to theta is 4 over the square root of 41. Look, I'm rationalizing again. Alright, that's a 1, by the way. When I do that, I get 4 square roots of 41 over 41. That's okay. Tangent. Opposite over the adjacent. Okay, opposite theta is -5. The adjacent is 4. No rationalizing needed. Cosecant is the reciprocal of sine. Now, here's a little math trick. To go to cosecant, if it's got radicals involved and you had to rationalize to get your sine or cosine, whatever, when it comes to doing the reciprocal of it, go to that fraction right before you rationalize, right here. Take that and flip this one over. When you do, that is your cosecant. You could re-rationalize all that, but you're going to get the same thing as if you just flipped it before you rationalized originally. I hope that makes some sense. So what you'll have is a negative square root of 41 over 5. Secant is the reciprocal of cosine. So again, I had to rationalize cosine, so I'm going to go to the fraction I had right before I rationalized, right here, 4 over square root of 41. I'm going to flip that one over, so I don't have to re-rationalize everything. So I have the square root of 41 over 4, and that's my secant. Cotangent, flip it over, easy peasy. This is negative 4 over 5. Now I have all 6 trig ratios figured out. All right, the last section has to do with the signs and the quadrants. All right, so let's think about this. Think through your 4 quadrants. Over here in quadrant 1, your x's are positive and your y's are positive. Quadrant 2, your x's are negative, your y's are positive. Quadrant 3, x's are negative, y's are negative. Quadrant 4, x's are positive, y values are negative. Now, using this information, let's look at what cosine and secant is talking about. Cosine, remember, is x over r. Cosecant is r over y. All right? Remember that r is always 1 on the unit circle. So really what this is saying here is that x is greater than 0, which simply means it's positive. And over here, this is talking about the 1 over y value. Okay, so whatever that value is less than 0, so that means it is really, my y value is negative. That's what this is telling me. So I'm looking for the quadrant where the x values are positive and the y values are negative. Well, look, only one quadrant fits this, and that would be quadrant 4. There you have it. That's all you got to do. Know your quadrants and know your trig ratios, what it's dealing with. All right, for the WISC, you're going to do this problem for me. Name the quadrant where the sign is less than 0, but the cotangent is greater than 0. Okay, think through your quadrants, think through the values, and tell me which quadrant this is true in. All right, good luck, and see you in class.